Hello and welcome to CEN 4801. In this session, we are going to address how understanding the problem will assist in identifying the right alternative solutions. Randomly putting objects together does not form a system. To build a successful system, you need to identify what's called system mission. Successful missions begin with a thorough identification and understanding of the problem/opportunity and the solution spaces. Looking at the different systems and their interactions with each other, you can see that one system's problem space may be an opportunity space for another that desires to capitalize on the weakness. For example, online retailers system would have the problem of getting the item to the customer, delivering the item. So a transportation system company can utilize or capitalize on that weakness to provide a solution of delivering that item to the customer. Actually, many examples could be applied in this situation, from businesses to universities to spacecrafts to set of laws. So the first step is to understand the problem that the user is trying to solve. Actually, people can become experts in analyzing system requirements. However, system analysis, design, and development success begins with understanding the user's problem/opportunity and solution spaces. The second step is to assist in putting the limitation, or actually the second step will assist in putting the limitations, constraints, and assumptions that revolves around the problem. So the second step will be understanding the environment surrounding the system, in other words, the operating environment. Human-made systems exploit opportunities and respond to threats. As an example of that, for any security breach or attack, there will be an opportunity to create a system that will detect and prevent intrusions. There are three types of opportunities. The time-based opportunity, which can occur randomly or predictably. If it's random, that's a matter of luck, and if it's predictable, it will be due to repeatable behavior of the system. Examples of random opportunity will be the implementing of intrusion detection and prevention system because of an attack that happened yesterday on the organization. The other type of opportunity is location based, which is being in the right place at the right time, waiting for the right location to be available to implement the proper system solution or the solution space. And with the fast pace of advancement in technology, a third opportunity arose, which is called the technology-based opportunity. One of the ways to capture opportunities is by exploiting new and emerging technology either through internal resources or by outsourcing to an external organization. Going back to the first step, which is understanding the problem space and understanding the problem the user is attempting to solve. The problem space differs from one organization to another. An organization might consider their competitors and their operating space as part of the problem space. The term problem has two contexts: a user perspective, where a problem space for the user represents an opportunity solution space for the system developer, and a system developer perspective, where system developer's problem space of defining or finding a design solution becomes an opportunity space for a subcontractor or a vendor or a consultant to offer a solution. So the user problem is an opportunity for the developer, and the developer problem is an opportunity for a subcontractor or a vendor. On another note, recognizing the problem space has two contexts. The threat context, which is eliminating vulnerabilities in the system to any external threats, and opportunity context, which is seizing the opportunity space to create a new system or provide a service to increase market share. In most cases, a problem will not exist unless there is a threat to the system. And to gain competitive advantage in the market, the organization has to be proactive in addressing the weakness that caused that threat. Other organizations are proactive in recognizing threats on others or on as their opportunity for offering the solution and mitigating the risk. Both organizations with a problem and organization recognizing the opportunity know that waiting for the problem to happen, then addressing it will cost way more and might impact other system operations. To identify the root cause of the problem, many why questions should be asked. Otherwise, the user or developer will end up solving the symptoms. For example, oil leak on the floor in a production line. If you replace the leaking gasket, that's treating the symptoms. Few weeks later, the leak is back again and the oil on the floor. So replacing that gasket was only treating the symptoms. Deeper debugging should be done to get to the root cause of the problem. And then we start asking questions. If the leak was because of the gasket ripping, we'll ask why did the gasket get ripped. If the answer was because of heat, and I'm just giving you a scenario here, then the problem solver or system engineer should ask another question: why the system is overheating? And then continue with these questions until the system engineer get to the bottom of the problem, the root cause of the problem. System problems evolve over time in a number of ways. Some problems occur instantaneously or as catastrophic events, such as hurricanes causing power outages or flooding and structure damage. Other problems could emerge over several years. The root causes for problems in system capabilities and performance originate from several potential sources, such as system neglect, which goes hand in hand with improper oversight or maintenance of system components. It could be also through ineffective training of user operators, which also goes hand in hand with improper use or abuse of or misapplication of the system. Another potential source is budgetary constraints, which can affect both maintenance and training, the first few that we talked about. In addition, the system degradation through normal wear and tear, which will be expected and might happen over years, but will happen faster with, of course, the improper maintenance and the neglect or negligence. And then the product or technology obsolescence, which might affect system integration with newer components or other systems in the organization. So we need to look at the compatibility between the all system legacy system and the new systems and the technology that's being used, and that could cause or be a potential source of a problem. So what's the manager's obligation in the rising of a threat or a weakness or a vulnerability or a problem? Some managers will be reluctant to report a threat until it becomes a problem. And sometimes they don't even report the problem until it's too late. Now, why sometimes they don't want to make their department weak or have problems, so they don't like to report, or any other reasons. So for the why, we don't care about the why. We care that if that happens, then if you don't report a threat, then that will become a problem. Now, other managers might not provide the proper priority to trivial issues until they turn into a major problem. So it's the manager's obligation to understand the consequences of ignoring those trivial issues on the system and how to prioritize solving these issues before they turn into a major problem. The challenge for most organizations will be to forecast the problem space of a system with the proper level of confidence. In most cases, management will perform a situation and gap analysis to current system capabilities and compare it to the capabilities and performance of competitors or a successful system. If a gap was identified, a search for the problem space will begin. Forecasting a problem could be easier if managers and researchers can determine the level of risk and the consequences of a potential hazard. To identify if the gap will be a problem, the organization slash managers, of course, within the organization should ask the following questions. Would the gap create a threat? What's the likelihood for the threat to turn into risk? And what's the impact of that risk on the system? At that point, thresholds for assessing the problem significance should be established. If the gap analysis leads to unacceptable outcome, then the gap is considered a problem. In some cases, system boundaries are vague, as we can see in the figure on the left. Systems engineering will translate the abstract, and this is where the system engineering role comes in and comes in handy to translate the abstract problem space domain into a solution space domain as depicted in the figure on the right. So what we did, we translated that vague environment or boundaries to a more defined boundaries that can be understood by system engineers, by developers, and assist in finding the proper solution space. Assuming the organization has the proper resources to solve a problem and it's within their sphere of influence and control, the natural tendency is to eliminate the problem. What you wish in an organization is to eliminate any problem. However, the reality is you may not, or the organization may not be able to eliminate the problem space, but manage and control, mitigate. At least, not to be of a risk for the system or for the organization. Now, before proceeding to any solution or solutions to the problem statement, the problem has to be defined clearly. What the problem what problem is the user attempting to solve has to be defined clearly. To develop a problem statement, the organization need to avoid identifying the source or root cause of the problem, identify the operational scenarios or operating conditions under which the problem occurs. So we're not identifying the source here at this point. We don't need to know the source. We need just to identify the operating conditions and the boundaries. And we need to avoid stating any explicit or implicit solutions. Even if I know any solution for the problem, at this point, I will not suggest or assume or state any solutions. And then we avoid assigning responsibilities or blame. It's not the time to blame. We need to look at the problem and analyze it first, understand it first. As an example of a problem statement, the desktop computers on the network are infected by a virus. So notice with that statement being said, that the statement did not specify the source of the virus, the impact of the virus on the network, or the solution or the suggested solution to such a problem. Although we might know the solution at this point, but we will not suggest any solution at this point. The reason for that any suggested solution without understanding the depth or the root cause of the problem might be treating the symptoms. Again, we don't want to treat the symptoms. We would like to treat the root cause of a problem. And this is how you develop a system. You need to look at the actual problem so you can develop the proper system that can address this problem. Now, what if the problem that's defined is complex? If the problem defined as a complex problem, then it can be partitioned, which will create a more manageable solution space for each sub-problem. With that being said, the identification of one or more solution spaces requires highly iterative collaboration, analysis, and decision making. And when we say iterative, means like going back and forth with the solution until we make sure that this is the solution that will fit all the partitioned spaces. Through partitioning, our objective is to isolate key properties and characteristics of the problem as abstractions that enable us to ultimately develop solutions. Another issue organizations should consider before investing in finding the solution is the level and degree of urgency of the problem space. When making the decision to invest or not, certain constraints should be considered, such as budget and technology and many other things. The figure in this slide shows how a complex problem space with one large box can be partitioned to several solution spaces, each focused on satisfying a set of problem space capabilities and performance requirements. The large box in the left represents the total system solution. The complexity of the system solution will be partitioned into subsystem level solution spaces. The solution spaces are characterized by a variety of boundary conditions. It could be distinct, rigid boundaries, for example, limited budget, which might affect the number of resources assigned to the solution space. It could be fuzzy, blurry boundaries, which means the solution space is vague in some way, which might affect the capabilities required, the priorities assigned, and the resources allocated to the problem space. And it could be overlapping or conflicting boundaries, which could be a mix of both the distinct and the fuzzy boundaries. In this case, the solution space will be determined by capabilities required under all boundaries, and the resources will be allocated based on that. When a gap is identified in a system or a product capability, it takes a limited amount of time to fill, especially if system development is involved. If the gap is of a defensive nature, the system or product may be vulnerable or susceptible to acts of aggression and hostilities from competitors. The vulnerability has to be addressed as soon as possible to protect company's system. If the gap represents a deficiency in an offensive capability, work must be performed to eliminate the gap by upgrading system capabilities and performance. In some cases, we need to deploy a decoy to um, distract aggressors until we fix the system and fill the gap. To address the problem space and required capabilities, the solution space should represent an abstraction of the strength, capacity, robustness, and reliability. The strength is the power to accept a specific type of mission challenge. Capacity to project, which is the ability to project a solution with 10x capacity with less cost. You don't have to build an expensive aircraft to cover X square miles. You need to figure out how to build reasonably priced aircraft that has the capability of 10x using other systems capabilities. Robustness, which is the capability to withstand threat attacks and accommodate internal failures. Reliability, which is the probability of completing a mission of a given duration in a specific operating environment. After understanding the problem and the solution spaces and defining the capabilities, the organization will select the candidate solution or solutions. Each solution space is bounded by technical technology, support, cost, and schedule constraints. Now, the challenge is to identify and evaluate several viable candidate solutions that satisfy the technical requirements and then recommend the preferred solution. The selection required establishing predefined objective criteria and then performing a trade study or trade-off study to select the recommended solution. For example, it might be costly but will provide the company with a competitive advantage and secure information flow. So it's a trade-off or a trade study that need to be done to understand the value or the trade-off between the cost and the competitive advantage. Every person in the organization should have exposure to and an understanding of the organization's opportunity solution spaces. System engineers should be more involved and should use their observation as critical skill for seeing, touching, feeling, operating, hearing, and studying existing systems in action. These observations will have a great influence on system engineering's throughout system development process. The last slide, as you can see, I put lots of information, so it's self-explanatory. Part of the problem solution understanding is to continue assessing requirements and the dynamics of the operating environment. What has been offered is not an end-all solution. We didn't end all the problems. Whatever has been implemented might have other reactions in the boundaries and also by competitors. So when the solution space is identified, the identification process might also consider. So when the solution space is identified, the identification process must also consider the potential reactions of competitors and how the new system, product, or service minimizes So when the solution space is identified, the identification process must also consider the potential reactions of competitors and how the new system, product, or service will minimize susceptibility and vulnerability to those threats, and at least for a reasonable period of time. That will be all for this session. If you have any questions, you can email it to me, or you can come in person to my office during office hours. I will be more than glad to assist you and answer your questions. Thank you and have a great day.